Welcome back, guys, to Chapter 4 of Learning Solidity. In Chapter 3, in our previous tutorial, we covered modifiers and error handling. In today's tutorial of Chapter 4, we will be covering imports and libraries. So if you guys don't remember, we will be using our original source code that we have been using for our previous tutorial, but just for today's purposes, since we are doing imports of libraries and other imports, I just wanted to tidy up this as well. So to follow along, you guys can label your first contract library.sol, and then we will also be making another one for library-test.sol. Is that we have our Pragma Solidity version along with our contract libraries contract. What we can do now is head over to library-test.sol, define your Pragma Solidity version. On line 3, going to implement import for our browser/library-test.sol. This is indicating to the contract that now this is our primary directory as to where we will be storing our files. Real world terms, or on a OS or Windows, that's going to be your directory where all your files are saved for that project. So also what we can do now is go down to line 5, define our contract, use libraries is libraries, and there we go. Now we have our directory for our import browser/library test, and now we have our contract, which is also universal with our library.sol. And for example, for libraries, guys, if we wanted to import a GitHub repository on our local machine, we would do something simple like this. We would put import or GitHub like normal, github.com/ your first folder. Of course, this is for me mtvta. There's nothing currently in this folder. This was kind of just for an example purpose. And then /solidity, and then / your library.sol, pulling that contract from where you stored it on your local machine. To our main library sol, we're going to also be implementing our string into our main library contract. So we know that within Solidity, strings have very limited functions in terms of executing increments. I want to say object, but that's not exactly it. So something that we can do with this, and this will make more sense when we do get into it, we can type in function, and then you do increment, and then we could do unit or uint, awesome, and then underscore self, and then we can close that and returns unit, and close our parentheses. And then we can also return this value. And what we need to do also for returning the value is remembering to give that +1 as we're modifying it. That's something to remember as well, that anytime you modify a value, especially within your function string, it has to be returned back true for any alternative changes. And then what we can also do the same is add our function I think it's decrypt, yeah, if I remember right, and then unit, and then underscore self, pretty much the same thing that we just did. Self, close our parentheses, returns, and then continue our unit again, close that, curly braces, and then return self, and then 1, and close. Oh, I'm sorry, that's supposed to be a -1. There we go. Awesome, guys. Just did a little cleanup of the code of our first library.sol contract. So if yours doesn't look like mine, you can get this updated. And if we go to compile just here in a second, it should compile just fine. And we will shortly be moving over into our library test. And when we get over to our library test, we will be assigning our integer so that we can start pulling our library data from our library.sol contract into our library.test. So if we do head over to compile, it should give you a green check mark for compiling version. Also double check to make sure that your compiling version is somewhat close to the newest version, to whatever you have for your Pragma Solidity, and it should compile just fine. I will have the source code in the description just in case I didn't explain things clearly, or if things look very different on your screen. Falling back over to our library.testSol, a couple things to remember as we're extending our functionality from our original library contract. You can see that things kind of do get very tedious and kind of repetitive, but that's not something really to worry about. So we will be doing a little bit of a copy and paste just to save some time, not trying to make this a longer video than it needs to be. So going back over to our library.test Sol, I typed out our first function for how we're going to be continuing to pull our functionality from our existing directory of our library.sol contract. So function, test increment, and of our unit base. So a couple things to remember when we were incorporating our unit base is that if we were to add 8 or any sort of any other number to our base for compiling, it would come up as an error. Sometimes that's not always true, but it's important to stay consistent when we do running imports and libraries from our directories, that if we are going to implement our unit in one function, that it does need to follow the true value of our previous. So we cannot add 8 to our unit function if that is not available in our current directory. So as we continue further, this will be explained a lot clearer. So I'll see in the next cut, you will see this filled out. And do remember, guys, that the source code is in the description. So I'll see you guys here in just a second. And once we get this all filled out, we can show the further functionality for what this will. Alrighty, since we have everything set up and ready to go, let's test out our contract and see how this basic decrease and increase increments can start playing a role into our contract. So what we can do with our first one for our test decrement is let's just type in the number 10. This should return us, we should be getting 9. So as you guys remember, if you guys don't, and also a quick reminder, I did do a little mess up. For those who are getting compiler error, if you hover your mouse cursor over the top tabs of where your contracts are written, it should give you a default underscore workspace or directory to where it is stored. As we are working with imports and libraries, we're going to be breaking this down is that we are importing a directory from our previous library on the same machine, and our import default workspace library.sol, same as here. You can import it via that way in case you're getting compiler error and you have your contracts or IDE saved in a different place. So going back down to our deployed contracts, if we implement 10, we should be getting back 9. Decrement from 10 minus 1 gives us that 9. And if we go to test decrement by value, so if we did 10 comma 6, this should be giving us 4, or I'm sorry, this should be giving us 4. Yep, and it sure did. So 10 minus 6 gives us that 4. Going back down to our test increment, let's do 11 and see if that gives us exactly what we think it's going to. Awesome, gives us 1, that test increment of 1, cool, great as well. And let's do this one more time. Let's do maybe a higher number. Let's do 12 and 5, or I think we can just do 12 and 5. Cool, awesome, call that by value, and that is going to give us 17. So awesome, you can see that everything that we did was correct in terms of giving us the correct numbers by increments and by value. So if we go back to our library.sol, we can see how this kind of played out. So if you guys do remember, when we did our function in our extended library, we did function increments and return by self value. So a quick reminder, and I know this can be tedious, is that especially when you're doing libraries and imports, once we get further down into our tutorial length and we start doing kind of Oracle pulling, and that's kind of getting more advanced, we just have to remember that if our main directory and our value of our contract is written in senses of self plus or have any value that cannot be changed, we do need to go back and modify those if we do want to change the output value. So if we wanted to not have the decrease increment of 10 and we wanted to have that maybe plus by 5, we would simply just plus this by 5 instead of 1, and that would give us a plus increment of 5. So hopefully that makes sense, and that was a quick fix in case anyone was having issues or any questions in terms of how these increments are discussed by the values of imports and libraries. Some real world functionalities and kind of uses for the libraries, imports and library sections for the Solidity contracts is one of a couple. Solidity libraries are similar to contracts, but their purposes can vary. Their deploy cannot be written to a certain address, so you cannot deploy a smart contract and receive Ether or any other cryptocurrency from a library import address. There are some security measures there. There are code that is executed in the context, calling contract. As a library, is just a piece of open source code. Its variables cannot be modified without being modified in the home directory. So there's a couple kind of notes to pick up there. But in terms of how this format is helpful in terms of real world situation, helping us, developers moving forward, is pulling existing context from existing contracts already. So therefore saving times in terms of, kind of just what we experience now. It was very tedious kind of in the, the function test increments and decrements, as you can see from lines 8 to about 20. So you can understand how if we would have already had done this previously with another contract, maybe for another client, just using kind of real world examples, it would have been easier to, of course, do our default / workspace and pull some existing data from our previously old contract. So as we continue further in the tutorials, we'll be going over some in-depth enums and how Solidity library use cases for like advantages, and how we'll get more advanced with them as well, because you can do a lot more with just local EVMs, just like I talked about earlier in the tutorials. We can start interacting with some oracles here soon, and that's where you can start really pulling live data such as the weather, future predictions, and any other data that is frequently updated, if frequently updated in terms of live data. So I hope this tutorial was helpful for you guys. All source code will be in the description. Any questions, please ask, and I am continuing to work through these and get better at teaching these tutorials. So thank you guys for your patience. All feedback is positive and negative is definitely welcome, but thank you guys so much. I will see you guys in the next one.